Hello, Neuro, who I think is going to be the only person really watching this one. So, I've just solved the signal edge detector. Isn't that just lovely? It's not the best solution in the world, and I kind of knew that going in. I'm a bit sleepy, and for some reason, I had trouble coming up with a valid thing to do for this part. This write one if changed by 10 or more. But anyway, I figured that because you said you were vaguely interested in this for reasons I don't know, um, I'd walk through the program I've got. I think it's something like 22 lines. And, maybe we'll all learn a little something about ourselves. So, basically, you gotta read a value from the input, compare that value to the value that came in before this one, write a 1 if this new value changes either plus or minus by 10 or more. Now, if it doesn't change by that much, we write a 0 instead. And the first output, the first in, is always 0 because we don't have a previous. So, this first bit here is the easiest to do, I think. This first output's always 0. I just have these 2 lines of code right here that move a 0 down and move whatever comes up to the left. Now, one thing I sort of worked out earlier today, you can store local variables, kind of, to the left and to the right. Just doing this. It's a move right operation, which sounds kind of dumb, but basically, you can send something to the left. It gets pulled in here, and it'll move it back to the right whenever we ask for it. And I'll kind of show you what I mean by that later. So anyway, these two instructions basically take care of that. In our case, they send a 0 down. We'll get to the rest of this later, but I like to kind of just walk through the inputs as they go, so, yeah. Alright, so the first thing I do here is move it up into the register. Good times. And then, I check to see if it's 0, and I jump to this LZ2 thing. I've named the labels in a very strange convention that made sense to me at the time, but suffice to say we jump down here, which tells us to move a 0 down, and then that's the end. I've always, when I write assembly, and I don't do it very often, I always like to stick an end label at the end, just in case I want to finish. I guess it's kind of like a return statement. I think that's bad practice, but I'm not an assembly programmer, so fuck it. Right, so we've already said that because a 0 came in. Actually, that check exists solely for... you know, I'm not even convinced this is necessary. It might actually reduce the execution time, though. I'm not sure, let's find out. Oh no, that was 1 cycle faster. Okay, we'll keep it. Alright, anyway. That actually makes sense, because I don't think this set of instructions is any longer now. Yeah, okay, anyway. So we move the 0 down, and actually this gives me an excuse to run through this thing, which basically performs this operation. It checks to see if it's been changed by 10 or more. And I'm going to spoil things now by saying whatever this box outputs is how much this new value changed the previous value by. That's what all this does. This box checks to see if that if that change is 10 or greater, and I do it like this. I move it up into the register first. I then check to see if the change is less than 0. If not, I jump to it's not less than 0. But if it is less than 0, I negate it because for some reason I find it easier to think this way. Basically what you're going to do is take that value in the register. Notice that no matter what at this point I've made it positive, and subtract that by 10. So yeah. Now if we subtract it by 10, so let's say we get a 10 in as the amount that it's changed by. So a 10, by our definition, should write a 1, because that's a change of 10 or greater. Similarly, negative 10 should write a 1 because that's a change of 10 or greater. Right. Because of that, I use the less than 0 operand. No matter what I'm saying, that the change value I get is going to be positive at this point. So if I subtract 10 and get a value that's less than 0, I know that whatever change occurred was of a magnitude greater than 10 in some way, because if it was of the magnitude 10, the 10 minus 10 operation will give us a 0, which is equal to 0, not less than 0. Okay. So, if we get to this point, we know that we have had a change of greater than 10, so we move the 1 down. Yay. And after that, we just jump to the end. Like I said, I always stick these stupid little return shortcuts in. They're bad. Don't do them. I do them, though, because I'm not an assembly programmer. And I probably never will be. This is the most assembly programming I've done in a very long time, actually. I do a bit of stuff with the JVM these days, but not a lot, and that's not true assembly. Whatever. So anyway. However, if the second time it was less than 0, we know that it wasn't a change greater than 10, and so we move a 0 down. That's all great. That's how I handled the change of 10 or greater. I couldn't really come up with a better way to do that mentally. I probably could if I looked at this again later, but it works. That's at this point, at this stage in the game, the problems are a little less trivial, and I'm happy when it works. Now anyway, what have we got going on up here? So as I said, we're kind of throwing the first one just down here because it's kind of a one-off. I do that to save, like, I don't know, I guess that's 7 instructions. Anyway, first thing I do is move up into the register and save that. And the reason I need to move up into the register and save it is that at the end I've got to stick it back over here, however I modify it. So I need a copy somewhere. I use the backup for that. There's probably a better way to do it, but for now it functions. Anyway, at this point I can guarantee that I've got something saved over here. And because this is going to hang with the right operation, as soon as this gets moved over here, I know that whatever the variable I saved up here is, I'm going to be able to pull it out if I do this sub left. This effectively gets us the difference, and we just move that down. The only thing left to do is a swap to get the value that was originally pulled in back into the register, and move that to the left. I then do this because basically if you want to execute an infinite loop, the best way that I can think of is to just do this. This sets us back up here, and so on and so forth. Anyway, this seems to work. Isn't that a party? Anyway, you know, I'm realizing now that this video is kind of, just for neuro, and everyone else is going to be devastatingly bored, or better yet, have no idea what's going on. Isn't that fun? So, because I know that this is going to bore everyone to tears, what if we did this? Let's go back and try the next problem for, let's see, I'll time myself 1 minute and see how far I can get. Okay. So we've got to read from in1 through in4. Okay. Write the input number when the value goes from 0 to 1. 2 interrupts will never change in the same input cycle. Oh, okay, so we've got to store the state of these 4 kind of in a backup. Oh, this is deliciously tricky. I'm going to stop the video here and possibly figure this out. I might actually just shut my brain off because I can feel myself getting sleepy. But yeah, this is a TIS 100. Let's introduce the game at the very end. It's a game about assembly language programming, kind of. To me it feels a little like MPI and assembly having a big spooky baby. That's a thing, I guess. And, yeah. That's just some massive fun. This is coding. This is what I do every day. Well, this is kind of what I do every day. It's not at all like what I do every day, but the thought process is largely the same. And the sad thing is, I like this stuff.